Alright, it's rolling. Alright, I am Mr. Trestle, in case maybe perhaps you don't know that, maybe you've seen me on campus. So to Miss Stinson's class, I'm going to be making some videos for you. There'll be a combination of videos that I'll make currently here at Crestwood, as well as using some previously recorded videos from another school that I worked at. So to help understand the content, I'm going to do that for you, and right now I'm going to play something that I recorded about 2 weeks ago. So here we go. Alright, that is rolling. Alright, let me talk to you. There I am. Hey, so we're moving right along, right? 7th grade is just trekking right along, and let's tie some things together, right? So in the beginning we were learning about the scientific method, and we were learning energy transformation, and now we're learning about waves and how waves carry energy. Let's take a step back and let's talk about you and the species to which you belong to, okay? Homo sapiens sapien, scientific name, binomial nomenclature. We'll get to that later. But we, as a living organism, as a species, right, have been discovering what is true and what is not true about the natural world. And that is really, truly the thing that separates us from the other members of this planet in the animal kingdom. All right? So, as a species, as humans, to be able to discern what is true and what is not true about the natural world, nothing rivals that. Nothing. Okay? It is what brought what we have in our culture, a patterned way of life that's socially transmitted in society today. It's brought us to where we are. Well, again, let's talk about you. You're 12, 13, maybe a little more. So you were born in 2008, 2009, 2010, somewhere around there. That's when you got here. That's when you got here, okay? And society, what we live in was already well underway long before you got here. And when you got here, it is the way it is. And that's slowly changing. All right, it's a slow process, but it does happen. All right, and by virtue of that, if you look backwards in time, things have changed quite a bit over time. All right, so I have some things to help you understand, to demonstrate. In a video I made, I brought this up. I actually, this back in 1989, this was the thing to have, and to have a little portable television was practically unheard of, especially me being 1989, I was 15. But anyway, Sony, all right, you heard of Sony. Sony made something called the Watchman. The Watchman. And the Watchman worked off of radio frequencies, all right, radio frequencies that would deliver picture and sound, television stations. Now, when I got here, when I was born, 1974, there were still many and most black and white TVs out there. In fact, my parents had a black and white TV for a while, and then I remember getting a color TV and it being a very big deal. And these antennas were mounted to every TV that there was, and usually there was 2 of them. And the longer the antenna, the better reception you got, the stronger the signal, the clearer the picture. And believe me, when I was your age, the pictures on TVs were nowhere near the type of definition that you guys are used to. But going back to this is a product, right, that human ingenuity has designed, right? You go back 100 years, nothing like this existed, So we as a species have figured out what is true and not true about the natural world, and are using ways to make it useful to us. How can we make our lives better? And that's kind of me going off topic here, but you look at animals that a beehive, bees make the beehives the exact same way. They have an instinct on how to do it. It's not a learned behavior. Ants make ant piles. Everything that they make, it works for them, but it's the same. Humans, we tend to like to make things better, So if something's good, okay, great. How can we make it better? How can we make it smaller? Televisions were large. How can we make them smaller? Now, between this one and today's, how can we make the screen, the resolution better? How can we, fit it into something that's even smaller than this, like you guys have a phone now, So what I'm saying is, here's an example of human ingenuity, okay? And this is an example of state-of-the-art. That means the best of the best for the time. Again, going back to 1989. In fact, the batteries here, expire in January 1993. And batteries usually have like a 5-year lifespan. When you buy them, they're good for 5 years in the future. So these batteries are from 1988. So yeah, just to put a little number on that. But
good afternoon, teachers, students, and staff. Please pardon this interruption, and teachers, I'll give you a moment to get all of your Eagles' attention. Thank you so much.
May have to come back to this.
Thank you, Eagles. Within a few minutes, the federal emergency test of the emergency alert system. It will happen momentarily at 2:20 p.m. So this is a reminder, as stated during the lunches. Please, all students and staff, please make sure that your phones are off. Now, we do have a couple of exceptions, and those teachers have already been spoken to with regards to those exceptions for those persons whose phones have to remain on. But all other Eagles, please make sure that your phones are in the power off position. As always, we thank you so much for your support and cooperation when we are conducting or engaging in any type of safety preventive measures.
I should have left it
The
rolling.
bell will ring momentarily.
I should have left it rolling because she said the word radio. Radio waves, cell phones work off of radio and microwaves. So there again, I wish I'd have left it running. We're trying to figure out how we can use what is true, what we've discerned that is actually there in the natural world. How can we use these radio waves to, make our lives better? Well, here you go. A way to nationwide transmit information through radio waves. Okay? So electromagnetic spectrum. We're going to let this alert happen, and then I'll come back to it. All right, so we're back. So you saw that. Now, the electromagnetic spectrum, as I was discussing in the video, radio waves were something that were heavily used for television broadcast. And back in the days of the 80s and 90s, that was the way of things. But that has since transitioned, and we are now using radio waves for other parts of technology. Primarily radio waves and microwaves, primarily for cell phones and internet, okay, Wi-Fi, things like that. So when you go this way on the electromagnetic spectrum with radio waves being over here and you work towards the other direction, you get into microwaves carrying more energy, then you get into the light, the visible light, including infrared, red, orange, yellow, green, blue, indigo, violet, as I discussed in the previous video, including ultraviolet. Now, X-rays. X-rays, maybe you've been hurt before and you've gone to the doctor and they kind of take that fancy picture of your body to see if there's any broken bones, all right? X-rays are very powerful waves that are able to penetrate our epidermal, our skin, and go through and get an image of, what's going on inside your body. How cool is that? Before the invention of X-rays in the 1890s, surgeons had to cut you open to figure out if you had a broken bone. So, it was a big deal. So this is what you call non-invasive. So heavily used in World War I, X-rays. And so gamma rays. Gamma rays are a very powerful wave emitted from stars, including our sun. And when we breathe out carbon dioxide, we all know that we, breathe in oxygen and we expel carbon dioxide. When we breathe out carbon dioxide, they call that carbon-12. Carbon-12 because it has 6 protons and 6 neutrons to it. And when we breathe out that carbon-12, it meanders around into the gases, mixing with the other gases, in the room and outside. It's picked up by wind currents and at some point gets brought up into the upper part of the atmosphere, okay? So you've got the different levels of the atmosphere, the troposphere, you guys remember all that stuff from 6th grade. But when it gets up into the exosphere, nearest the outermost reaches of our atmosphere, the sun's energy is strongest, okay? So the gamma rays emitted from our sun will hook up with the carbon-12, giving it 2 extra neutrons, making it carbon-14. So carbon-12 that we expel out, or any air-breathing organism expels out, could be a cow, a dog, you, that carbon-12, once it gets up into the upper part of the atmosphere, hooks up with the gamma rays exposure, hooks up with 2 extra neutrons, plugging in, making it carbon-14, which is radioactive. Now I bring that up because we're going to be going into how we do carbon dating, okay, when we're talking about history of Earth and fossils and how organic living material can, science has come up with a technique on measuring the radioactive carbon-14 within a material. We'll get into it later, but it has a half-life of 5,730 years, which means every 5,730 years it cuts in half. The amount of carbon-14 cuts in half, becomes nitrogen. But we'll get into that later. All right, but point is, gamma rays, okay, very powerful waves in the electromagnetic spectrum. An example of gamma rays, like I just mentioned, coming from our sun. Let's go back to microwaves. So microwaves, the story that I heard was that during World War II, the military was using radio frequencies to transmit information, basically communicate in long distances. And in those frequencies, as you move up into so we talked about hertz, when you get it past like the 3,000 hertz range, you get into the microwaves, and they were using towers to transmit frequencies getting into the radio and microwave range. And so there was a soldier, might have been an upper like a lieutenant or something like that, who had a chocolate bar. Just try to imagine like one of those like big like Hershey Kiss chocolate bar things with the foil. Had a chocolate bar in his pocket on his shirt. So a button-up shirt with a pocket, he had a chocolate bar there. And he was out on the field where they had these towers, and they were basically sending radio and microwave signals. And the chocolate bar started to melt, and he happened to notice that, and it happened to be coincided, going right along with as they were, using potentiometers to turn up the power for these transmitters. And so when he realized that amongst that power voltage of the transmitted microwaves, the chocolate bar started to melt, he actually took notice of that. And so it was brought up that happened. Scientists began to look at it. Turns out microwaves, okay, because when I say microwaves, there's an appliance called microwaves, but microwaves pair really well with water molecules. Water molecules are found in our food. So now going to the appliance. When you put something that you want to heat up, food, into a microwave and you turn it on, it's got emitters, tuned emitters, that are pointing those microwaves at the item that's rotating, and the water molecules start to vibrate, okay? If you ever rub your hands together, you feel that heat, that friction. So when you get this occurring within the appliance, the water molecules from the microwaves being emitted to the food have water molecules, and then those water molecules and molecules start to vibrate, creating heat. So it's how food is heated up in a microwave. So kind of a fun example. So going back to World War II war sometimes creates technological advancements. All right? What I mean by that is, in a war setting, some of the development, some of the items that are produced because of war, like a submarine. You know, it's an actual, something that was designed and implemented and, you know, became useful for wartime. When wartime was over, those submarines were still available, right? So we're going to be getting into, and I'm kind of like segueing into the coming unit, we're going to be getting into how seafloor spreading, okay, the movement of continental plates, okay, basically like we have 7 continents today, where they are, but they're slowly moving, and you're going to learn that about the rate that your fingernails grow. And so go backwards in time, those continents were in different locations on Earth. At one point, all connected essentially to one large supercontinent called Pangaea. There's Panthalasia. So anyway, during war, we had these instruments of war, you know, submarines that could go really, really deep. And if you've ever been to the bottom of a swimming pool, you feel that pressure on your head. That's because the weight of the water is on you. So the deeper you go, the more pressure there is. So kind of the challenges with trying to go deep is that you're dealing with, you know, high amounts of pressure. So you have to have a structure that can withstand that type of pressure. So when seafloor spreading was first suggested, it was by a guy by the name of Alfred Wegener, 1930s, 20s, 30s, and he was a meteorologist. But anyway, he suggested that the continents were moving around and that he didn't quite know what the mechanism was. He didn't know that there was seafloor spreading, but he had an idea based on some fossil evidence that there was evidence suggesting that at one time in Earth's history, let's just say the continent of South America and the continent of Africa were once connected due to plant and animal life. We're going to learn about strata, but they were finding fossils that said that there were animals and plants in the same spot at the same time on these 2 different continents, and they're now separated by, you know, the ocean, you know, the Atlantic Ocean. So Alfred Wegener had this concept that the continents were once in different locations and maybe even once connected, and the scientific community at the time laughed at him, and Alfred Wegener went off to, you know, vindicate himself to get more evidence, and he actually died, froze to death on an expedition. But going back to the military, in the 1950s, when war was over, the scientific community said to the military, may we use those decommissioned submarines for exploration of our oceans? And so they were allowed to, and it was at that time that we discovered seafloor spreading, which turns out to be the mechanism that causes the continents to move around. All right, so dynamic Earth, which is coming, has to do with seafloor spreading. It has to do with continental plates, and we're going to learn about subduction and uplift and all that. But going back to, oops, sorry, I saw a little red thing. Going back to microwaves, and I said the story of wartime, and then the kind of the advent of the submarine helped us as a species understand how our Earth has been changing, because we're actually able to observe where the seafloor spreading sites were occurring. All right, so very, very deep, like, you know, euphotic, where there's no sunlight. It's like so, you know, it could be a beautiful, you know, 12 o'clock noon on a blue sky day, and you start to descend. And there's another example. As you descend underwater, you start losing the colors of the rainbow, going back to visible light. You start losing red, then orange, and yellow. And as you keep going, you lose all these colors until you get to where there's no sunlight. They call that the euphotic zone. All right, so it's called attenuation, light attenuation. But anyway, that's just kind of a preview to what's to come. Today, you have an assignment that has to do with reflection, refraction, and absorption. All right, so you're still in the Unit 3 of visible light and the electromagnetic spectrum. All right, so there you go. There's that. Have a good day.